right. Thank you guys for joining once again. Today we're going to be talking, as Will said, about the Micro ATS Industrial. The Z-ATS Industrial. It's the newest addition to the Zonit ATS lineup. I'm Danny Latzer. I've been with Zonit for about a little bit over 10 years at this point. Serve as the Western Region Sales Director, and in many ways kind of the holder of Zonit knowledge, just from sitting in the chair for a long time. So I'm going to be going over some of the technical coolness of this new solution and applications with you guys today. A little bit about Zonit, if you're unfamiliar. I mean, really, we're an IP company, so us releasing new solutions is kind of on point for us. We really are an entity that invests in patentable products and solutions. Mission critical environments has been our focus. We're in Boulder, Colorado. You can see a nice little picture there of the Zonit offices with the flat irons behind us. And we really focus on power solutions for mission critical environments is really where we kind of spend our time. Those solutions have really gotten us a lot of asymmetric attention from those out there of mega importance in the landscape of mission critical infrastructure. This is the product that kind of put us on the map, our Micro ATS, which focuses on power redundancy. We also offer Z-Lock, which is a power path security product, and then the ZPDS, which is a three-phase power distribution solution. Very cool if you haven't learned about that one. It's kind of a Swiss Army knife of a PDU offering. For IDF and MDFs, it's about as ideal as one can get. But today we're going to be focusing, for the most part, on our ATS line and the expansion of it. So for those of you who are very familiar with Zonit's Micro ATS, this is going to be old news to you. We offered a long time ago the world's first and only zero-U ATS, just like every other ATS out there, provides dual power redundancy to single corded devices, but difference is that this one is incredibly small. So whereas your typical ATS is rack mounted multi-port, our ATS is about the size of an iPhone. Very, very small. They don't take up any space within the server rack. Very easy to deploy. And despite being ridiculously small, they will transfer at any phase angle, even 180 degrees out of phase, which makes them incredibly easy to deploy, but more importantly, very difficult to deploy incorrectly. So that alone has gotten us a lot of attention. Other features that people find appealing are that there isn't any programming required, so no firmware updates, no software updates, nothing like that. It's a simple analog switch, just plug and play. Go ahead and pop it in, take advantage of any available receptacle in the plug strip and go to work. And people really love that one-to-one solution ratio. So previously, if you saw that multi-port ATS that's rack mountable, God forbid that entire thing would be utilized and it should fail, then one thing failing causes 8 or 12 things to fail. With the Micro ATS, we're minimizing that exposure to failure while maximizing the availability. Those things have all really got us a lot of attention, and it's kind of the first thing on the map that we had for Zonit that was starting to get us a lot of that attention. Applications, pretty commonplace, and those of you out there who are familiar, probably using a lot in the data center space, IDF, MDF space. Now, anyone in general who's dealing with networking, datacom, that type of stuff, these things have been wonderfully productive and useful for those in the landscape of networking. It seems that one of our largest pairing entities and utilizations out there are in conjunction with network switches. We could literally kiss Cisco for all the business that they've incidentally thrown us our way. But the truth of the matter is that we started to see some other applications pop in, OEM industrial applications, right? Things that we had never really built this for, but people out there in the land of usership are smarter than we are, and they started to see a good idea and figure out new ways to utilize it. And with that, one of the things that they started doing was taking this ATS that you're seeing in front of you right here and slotting it into their automated control panels for mission critical applications. So, what you see here is a controller for, I believe this one's an HVAC application, but essentially HVAC has been one of the big ones because they just can cut and paste this in for dual power redundancy rather than having to engineer in something else. So HVAC pumping, monitoring, traffic applications, fire panels, so emergency applications have been quite useful out there, and manufacturing. We've been seeing these things get deployed out there on a manufacturing floor in conjunction with some automated robots and whatnot. And the big question that people have is why? Why is this suddenly becoming an application after however many years? And the answer is pretty simple. The historical methodology for maintaining these automated control panels and providing power and operational continuity has been to use them in conjunction with UPS, or uninterruptible power supply. It doesn't really matter what flavor those take. They can be something for a facility, they can be something for an application, or they can be something as simple as a desktop. But historically, pairing these in conjunction with a UPS or those automated panels with UPS has provided people with the peace of mind and the operational and power continuity that they were seeking, except when they don't. Let me explain. The folks that are the juggernauts within this landscape, people like JCI and Siemens, they started using our ATSs as an OEM component because they realized that really there are two challenges to operational continuity that keep on popping up. The first of which is scheduled maintenance. And that just means if you have things that are in line, oftentimes you have to take them offline in order to provide a maintenance to them. The second is UPS failure. You might say, what? And I'll say, well, it's interesting that those folks who are kind of utilizing these UPSs in conjunction with these automated control panels for that operational continuity, in many cases actually found that UPS failure, or the UPS itself, was responsible for the lack there of that operational continuity in a lot of cases. So why is that? Reason is that the way that things are oftentimes laid out is you've got your UPS, and then you're feeding that with the panel, and then you're attaching that on the other side of it. And ultimately a UPS is really just batteries with some logic, and batteries with intelligence, whether they happen to be, still need to be monitored, serviced, and changed. So if those aren't performed on a regular basis, well, UPSs die, and then oftentimes whatever it is that's on the other side of that is going to go the way of the dinosaur along with that UPS. So that being the case, go ahead and enter the industrial. So these companies that have been utilizing our ATSs in that application came to us and said, gosh, we really like your ATS. Would be even better if you can add in a bunch of other features to it. So we've been using it in this capacity, as you kind of see right here, and we'd love it if you could kind of make something tailored for the application. So we did. And what you're seeing here is our newest offering. It's the Micro ATS Industrial. And this picture doesn't really reflect the actual size. The size on these things is actually much more akin to that of an iPhone. These are about 3 by 6 by 1.5. So if you took a couple of iPhones, 2 or 3, and stacked them on top of each other, you'd be getting the form factor right. But really, it's about the same size. So, very, very easy to slot into an automated control panel enclosure. They fit very nicely within that space, and people are using them because they add cut and paste redundancy. So now those systems that are attached to this can be fed by both the UPS and the utility. And if something should happen to either one of those feeds, then our industrial will bounce to the alternate feed, and the attached system will remain energized, continue operating as if nothing ever happened. Adding in that resiliency is pretty nice because, again, it doesn't matter what it is that you're doing out there. The redundancy, the resiliency is great. It provides that operational continuity. The flexibility component of this it comes in when your UPS does die. Guess what? You're still going to get that phone call, that email, and that text message at 3 o'clock in the morning, but the person that's in charge of that facility is going to be able to double check their systems, see that those attached systems are still energized, and then they can roll over, go back to bed. When they get into work in the morning, now they can go ahead and schedule that maintenance, and they can do it during regular business hours at regular business rates. So that flexibility is really the big key. I think why people really like this is it makes their lives easier, the people that are in charge of those spaces, but it does add that extra element of operational continuity to those systems, another layer, if you will, of protection against bad things happening. So here's the typical way that people can deploy, or at least this is the lowest cost way to do it, is basically you're just tying in to the system that you're seeing right here. I don't know if you guys can see my mouse or not, but I can go ahead and annotate if you like. So you've got the little tie-in right over this way, and then as you've got that tied in, you're feeding over on the other side and ending around that, so you're feeding this SBC module down over that way, which is pretty darn nice. Kind of allows you the opportunity to get this stuff up and running, and if there's anything else that you need on that, you can go ahead and get it done. But we're essentially providing redundant power and the ancillary benefit of a maintenance bypass, which is very, very fun. So now people have the opportunity to not only get this thing so that it's working around on it, but it is going to provide people the opportunity to work on any given part of those systems while the attached system remains energized via that that maintenance bypass feature that it provides. Some people out there might be saying this is not the most ideal way of deploying, and I'm going to say you are correct. We still do have the problem over there of a single point of failure, as you can see right over in the corner, and that's why we'd recommend providing this ATS with a differentiated circuit, whether that be from a wholly circuit there on the same panel. We'd ultimately say that the best way to do it is to send a circuit over from a completely differentiated panel so that you have true power diversity on these things. But this is how a lot of people are deploying these out there right now. And these have been deployed now in the thousands, to be quite fair. We first launched this solution back in the day with CE in the European theater before UL took their sweet time and gave us their blessing. So we do have CE at this point, as well as UL, as you can see on this picture right here. And it seems like a question just came in: how many have been deployed? A lot. A lot of these have been deployed, thousands to be quite fair, and they're deployed, back to Bruce, your point earlier, in data center environments. So Microsoft has actually been a pretty big user of these in conjunction with JCI automated controls, oftentimes for HVAC applications. But we also see, again, some of those other ones that we talked about earlier. And part of the reasons that they're doing it, as we've already discussed, are pretty open, but they really like the feature set. Essentially, those guys came to us and asked us if we could add a whole bunch of features to our existing ATSs that would speak a little bit more concisely to the industrial application. We were able to get about 95% of what they asked for in. First thing that they said is, we really like your ATSs, but it would be nice if we had a one size fits all kind of a solution here, so that we didn't have to specifically dedicate for a European versus an American versus a Japanese voltage. They just wanted to have something that was a one size fits all, could work on either side of the pond, and was plug and play universally. And for that, we went ahead and got them a model that was auto ranging from 100 to 277 volts. And if somebody does want a custom range so that the over and under voltage thresholds are more commensurate with their application deployment scenario, we can go ahead and dial that in as well. We can also go ahead and get you a little higher capacity. So before, people were kind of up against the edge of some of their capacity restraints. Our HV was at 8 amps, our LV was at 12 amps, and this one is going to go up to 16 amps. So essentially, we're trying to get something that tied in the entirety of a circuit so that they could just pair it with whatever circuit was feeding the application, and this would provide the cutoff. Also threw in some cool features like current limiting technology. So, though in a data center things are pretty tight, in industrial applications, that's not always the case. Things get a little bit more loosey-goosey, and sometimes, especially if you're dealing with things like VFDs, variable frequency drives and whatnot, sometimes there can be some harmonic resonance that provides a false feedback loop. And what we have here is a Z-crush, is something that we've added in that's going to help protect against those potential transients resulting from the differences of the primary and the secondary power feeds. So, a little bit of added protection goes a long way, and we certainly wanted to throw in some of those with this, as they were going to be in more industrial environments. So we also threw in some voltage protection as well, adding in some MOVs and metal oxide barrister helps to smooth out any of those voltage transients which might pop up. And though this was designed to slot into a max 277 volt environment, these things in our lab are actually taking 480 volts per minute. So very resistant and resilient and very, very strong construction on these things. They're going to take a licking and keep on ticking, kind of like a Timex. Also, whereas a data center, the thermals in there are pretty tight as well, and those envelopes are pretty narrow. Not the same with not the same at all when you're dealing with things like an industrial application. So these things might be used in an air handling controller, which could be on a rooftop in an Arizona summer, just as easily as they might be on something on a pumping application in a Canadian winter. So we wanted to have a very wide operational temperature range. When we first launched this thing, I think we were sitting at -5 to 70 C, which is 23 Fahrenheit to 158 degrees Fahrenheit. But in our labs, we've started to test that a lot further as we've started to get some pings from people on other applications, and turns out that these things operate perfectly well down to lower thresholds. In fact, we have units in our lab operating at 100 degrees below 0 Fahrenheit. And since we're not really expecting a whole lot of cryogenic applications, we're actually shooting for a -40 to 70 C operational temperature range, which is about as far as anybody's really going to need something out there in the land of genuine and real applicability. So there it is to be said. A question came in from Bruce Sutherland. Bruce, how difficult is this to be installed to existing systems? Not very difficult at all. In fact, folks like JCI and Siemens are running these things out there right now and doing field replacements for things like time delay relays and relays that they have deployed in their current systems, because this is going to give them better functionality at a better form factor. And it has some things, the features that we've already discussed, that make them even more appealing than the existing things that they've Frankenstein and cobbled together to accommodate the same end goal. So not very difficult at all. In fact, we've made them incredibly easy to deploy, and I'll tell you why. First off, and your timing couldn't be better, Bruce, they're DIN rail mountable. So we've added in that functionality. The case that you see here is extruded aluminum with integrated T-slots. So you can go ahead and directly mount, as you can kind of see right here, a DIN rail into them, which makes them, again, very easy to install into existing systems. Or you can go ahead and just slot in, because of those integrated T-slots, a secondary or an adapter that can go ahead and clip on with a spring load to that line as well on the DIN rail. So we're making them as easy as possible. Another question. Somebody just asked me if they come with DIN rails or not. They don't come with a DIN rail, but DIN rails out there pretty easy to go ahead and find wherever you want them, or oftentimes already installed within your constructs. And as far as those DIN rail kits go, those are a dime a dozen. We could certainly sell one to you, but it'd be easier for a lot of times if people just went out and got them wherever they prefer to get them from. Another big thing is that these things will start on A or B after total power loss. A lot of times in data center applications, the ATSs that are utilized within those, they do have a preference, but industrial applications, it's not as clean, again, as a data center. If a data center has a fire sale, whatever power comes back on right away isn't necessarily the best way to start those up. They want to start it in an ordered fashion, not necessarily the same case in industrial. So they're going to take whatever power comes back and is available first. So this will start on the A or on the B, doesn't care. We just want to get you back up and running. Also, speaking to Bruce's question, how difficult to be installed, we've got these things coming out in a couple different flavors. One of those is that we're going to have bare wire ends on these rather than being finished with connectors on them. And that's going to make them easier to slot into terminal blocks. As you can kind of see here, it's a 6-pin terminal block. Bare wire on the end just lets you slot them in there and take advantage pretty easily. Though we will also have corded inputs and outputs with connectors available on them. And ultimately, our goal is to have right where you see here with these little ends and this little kind of connector base with the cords. Ultimately, we're shooting to have one of those that's just slotted in as a terminal block. And as soon as UL gives us our blessing on that, we'll release that model as well. We just wanted to get something out there into the landscape that would accommodate people's immediate applications, and there were plenty of those. So sometimes it's easier just to give people what they want rather than duking it out for what they really want, and then fix it on the backside. Some nice visual feedback loops on these things. So this whole backside here is an actual light bar, and that's going to give you some nice visual indicators so that people can take a peek and see what's happening with it just by looking in on the model. If you see a solid green light on, that means that it's on the primary side and it's active. If you see a solid blue light, it means that for some reason it's bounced to the secondary feed. You should probably go and check and see why it is that that primary feed isn't available. And then we do have a nice feature that people had been requesting for some time, and that's the secondary power feed will blink to show you that it is present and on standby, but not currently active, which is a pretty nice feature on there. And that basically kind of runs you through the marquee features on these things, the applicability of them, where we're seeing them being utilized. But I would really love to kind of get into some questions for you folks. A lot of people have asked things like, who's using these? And the biggest answer so far is those who are in the landscape of automated controls to date. So Siemens, JCI have been big users, and they're kind of juggernauts in that field, but we're seeing some smaller panel houses and regional panel houses use them, again, just slotting in as a OEM component in their constructs because it's just easy. We're also seeing end users utilize them in the capacity of universities. Think of anybody who has large campus builds with a lot of automated controls and a lot of mission critical controls within them, educational entities, healthcare campuses, corporate campuses. I mean, these things are being slotted in with fire panels and HVAC applications, elevator applications, manufacturing applications. So those who are, as you can kind of see behind me on the production floor, there's a lot of little things out there that need to run 24/7, 365, and those single board computers that control them, these are great ways to provide operational continuity to them as well. So those are who we're seeing as a lot of the big users.
Danny, in my case, I usually deal with, facilities, people in universities and hospitals. So this sounds like this would be something good to take to them, to take to the gray panel stuff in the back room and the other closets and stuff with the facilities. Is that a
100%? Yeah. In fact, speaking specifically to where you are, I don't know if you're familiar with the University of Rochester, but one of my pals over there, Gary Runyon's in charge of all their IT and in charge of kind of facilities as well. And I had given him a sneak peek of this long before we had it released with UL or any of that stuff. And the second that it got UL blessing, he bought them and installed them. So he's using these for a lot of his critical controls out there, and certainly things that within the university application, he says that this is his new standard. So I think you'll find a lot of success if you can find the facilities folks within universities for sure.
What is the turnaround time?
Oh, lead times for these. They're not bad. Especially right now when you're talking about everyone in their supply chain woes. I think that everyone's pretty familiar with it's going to be 26 weeks right now. Not the case here. These things are actually manufactured in North America, which is super cool. Means that they're not floating over on a slow boat from APAC and waiting another 3 months just to get into the West Coast ports. So right now, we're looking at typically lead times of 6 to 10 weeks, depending on what it is you're looking for, the quantities and the volumes. The cool thing is, and for those of you who are kind of looking to, get your brain running on why it is you want to sell this in the first place, oftentimes it's a one-time introduction that has recurring and long-term use from the users on these things. So, we're getting orders from JCI for 500 units at a time, just to provide some context. And they're ordering multiples of those on an annualized basis. So, really the volumes here, if you find the right user, are going to be pretty darn high. And the return rate on those orders is going to be pretty frequent. Essentially, this just becomes a new slot-in OEM component that they rinse, repeat, and reuse on a regularized basis. So, we think that, that's a pretty key component. The folks that you find, if this is something that speaks to them, are going to slap their forehead like they could have had a V8 and ask you where the heck this has been for the last 10 years. So at least that's been my experience so far, as somebody who's kind of done some of the, preemptive work and touching into some of those users and some of those paneling guys. I'd sent something even blind to people on LinkedIn, and their response to me has been, we need to talk, as opposed to ignoring me. So I'd say that it bodes well for utilization out there in the marketplace. Anybody else have some questions?
I have one. How are they priced?
That was exactly what I was about to answer. I saw that one come in. I was going to say, one of the big questions people ask me is, how much do they cost? And really, they're not a whole lot more expensive than our existing ATS line. So right now, I want to say list price on these runs somewhere from $470 to about $585 is list on these. And discounts come down off of there for trade and registered and stock pricing. So really, it's right in line for the most part with our existing ATSs. Maybe a little bit more expensive, but super duper cool that we're not trying to gouge anybody in any way. And really, we were surprised at how affordable they wound up being after we got done building them all and getting it through all of the approvals from UL. It's a very affordable price point for the people out there who are doing it. Kind of negates having to work an engineering cycle to try and, again, Franken engineer something into an enclosure that's going to provide the same thing, but instead doing it with relays and time delay relays. So this is something that works very, very well at a very appealing price point for the application. Somebody's asking if they can get any samples or evals, and the answer to that is we absolutely can get you a sample or an eval. Typically we give out these things for 30 days, let you put it through the ringer, test it, make sure that the sky doesn't fall. Most of the people that have done that have come back very, very happy. The other people have come back ecstatically happy. So we're only dealing with people so far who have tried it and liked it. To date, we haven't really received a whole lot of negative feedback on these things. So I think the price point and the feature set is right on point for who it is that we're trying to message this to. And the proof is always in the pudding. If somebody has an interest in them, let us know. We're only too happy to get you a sample so that we can prove it. All right. Well, if there aren't any other questions, it seems like we might have done our job here. So with that, I will say thank you all for joining, and feel free to touch in with us. We've got folks here at Zonit that are ready to help you sell these things or at least explain them. If anybody's out there in the land of controls, obviously we want to help connect with the people that you're working with and provide some anecdotal information as to who's using them and how. It does speak volumes that those big hitters like Siemens and JCI are using it. If there's anybody else out there that is within that milieu, we think that this is going to be like, offering candy to a baby. They're going to want it pretty badly. So let us know what we can do to assist you folks with your efforts. And if there's any questions that pop up, if you're like me, normally I have my best question about 2 seconds after these presentations end. Please feel free to reach out and we'll get you sorted out.
Awesome. Again, thank you, everybody. Thank you, Danny. And I hope you all have a great rest of your day.
Thank you, guys.
Thank you, everybody, for showing up, and appreciate your time.